Hey guys, Mr. Backerberg here. In this video, we're going to look at average rates of change. The average rate of change of a function over a specified interval is the amount of change divided by the length of that interval. So if you think about it like driving a car, it's how far you're going divided by how long it took you to get there. That would tell you your average rate of change or your average speed in your car. So if we want to find the average rate of change for the function f of x equals x cubed plus x over the interval from 1 to 3, we first need to figure out where our function is at these endpoints. So at an x value of 1 and at an x value of 3. Well, if we talk about that x value of 1, if we want to figure out where our function is at, we're just going to plug in 1. So we would do 1 cubed plus 1. 1 cubed is 1, plus 1 is 2. So at the x value of 1, we're at 2. But now if we wanted to talk about the x value of 3, we're going to plug in 3. So 3 cubed plus 3. 3 cubed is 27, plus 3 is 30. So now if we want to find the average rate of change, we first want to figure out how much our function changed by. So we're going to look at those y values, and we're going to find the difference between them. And then we want to take that answer and divide it by the length of the interval. Well, the interval went from 1 to 3, so if we find the difference of those, we would subtract them. So if we take 30 minus 2, that's 28. And if we take 3 minus 1, that's 2. And 28 divided by 2 is 14. So on this interval from 1 to 3, our function had an average rate of change of 14. And really, if you look at what we're doing, where we were subtracting those y values and then subtracting those x values, essentially what we did was find the slope between these 2 points. So the average rate of change between 2 points on a nonlinear graph is the slope of the secant line that connects those 2 points. And a secant line is just a line that intersects a graph at 2 spaces. So if we had, say, a parabola shape, and we wanted to draw a secant line, say we had this point down here and this point up here, we would connect those 2 points with a line. Because it hits my graph in 2 places, that's a secant line. And then we could find the slope of that secant line, and that would represent the average rate of change between these specified points. So taking a look at this example, we are talking about growing fruit flies in a lab. So the graph below was made by counting fruit flies on regular intervals. So on day 23, we counted 150 fruit flies, and on day 45, we counted 340 fruit flies. And what we want to do is figure out the average rate of change on the interval between the 23rd day and the 45th day. So we're going to take those 2 pieces of data that we were given, and we're going to turn them into ordered pairs or points along this line. And then because we're calculating the average rate of change, essentially what we're doing is finding the slope of that secant line between those 2 points. So on the 23rd day, there were 150 fruit flies, and on the 45th day, there were 340 fruit flies. So we want to find the slope of the line connecting those 2 points. So if we subtract those y values and do 340 minus 150, and then subtract those x values, 45 minus 23, well, on top, 340 minus 150 is 190. And then on bottom, 45 minus 23 is 22. If we look at dividing that out, 190 divided by 22 is about 8.6 flies per day on this interval. Now, in addition to know how fast the population grew between day 23 and day 45, we might want to know how fast the population was growing exactly on day 23. And if we think about that line that we drew in, it's a nice steady path from that 23rd day until that 45th day. But if we focus on what's happening on the graph, it looks like at the very beginning there was a much more rapid growth, and then it kind of leveled out towards the end. So that 8.6 flies per day might not be a very good representation of what's happening exactly at day 23. So what we could consider doing is finding points along our graph closer to day 23 and finding their slope because that might give us a better representation of what's happening here. And ideally, what we would want to do is get as close as possible to that day 23, so that as we find the slope between those 2 points, it's more representative of what's happening exactly on day 23. So as your points get infinitely closer together, that approaches the slope of what's called a tangent line. And a tangent line is a line that just barely touches a curve at one point. So that would give us a better idea of what the growth rate is exactly on day 23. That's going to be it for this video. Thanks for watching.